All right. So, preview. We've been doing some of this stuff since like the very, very, very beginning of things. What do I need to do on the first one to get R alone? Divide by -4. Okay? Even though we see the minus there, this isn't one that we are attempting to add or subtract from. Right, so it's just attached to my R. It's not like there's one in between. Okay, we'll have to get it made up. Yes, sir. Okay, good question. Why I wouldn't add here? Let me explain the difference. If this was written like this, and I saw a plus or a minus in between, notice how here it's just -4R, here how there's a plus in the middle. Okay? When there's no plus or minus in the middle, I'm multiplying here by -4. So the opposite of multiply is to divide. Right, but if the problem were written this way, that's when I'd be able to add. I can't add here. Because I'm not subtracting 4 from R, I'm multiplying it. Doesn't look like it. Okay. Nope. Not yet. I think there's some graphing later. So on the second one, speaking of that, what's my opposite I need to be doing? I have to multiply. And again, a lot of these at the start are just trying to warm us up and get us situated into that. Yep, 24. I'm sorry, it kind of got smushed, didn't it? Okay. So that's what we're looking at as far as that goes. What about the third one? Okay. Here, this time I am subtracting. It's in between them. So we're going to add the 13. Ooh, but then, what's -6 plus 13? So nothing too bad there so far. 4 is our first two-stepper. What do we need to do? Yep, times 5, because we're trying to get that 2x by itself first. So we're going to times both sides by 5. A little more light on the subject here. And then that's perfect, okay? But again, when you're trying to figure out what to do first to solve for x, the biggest thing you've got to think about is what's furthest away. Okay, this divide by 5 is further away than the 2 is, but right next to it, so I got to do that first. All right. Start changing up a little here. About 5. Okay, good. Here, sometimes we see that minus and we think, something else. This is a positive 6. Right. It's a negative x. Now, so what number does that mean that it's in front of negative x? In front of x. Spit it out. Okay. So this is like a -1. So I'm not quite done yet. Okay. It's right. Since I'm multiplying by -1, I need to divide. A positive divided by a negative is a negative. So there's lots of little detailed stuff that we can do to try to get ourselves set up well for these. So 6, same idea, except now it's an inequality here. How do I get that 6 out of here? Subtract the 6. what's my last step going to be? Okay, divide by negative 2. Oh, nice. Okay. Okay. Let me explain why we have to switch the sign. Correct. Correct. So yeah, on one of these, right, if you're dividing by a negative, both sides, then we're going to have to split the arrow, because otherwise our values don't come through correctly. Here's the one that gets everybody on every quiz. Let's see if we can avoid this time. Okay, well, sometimes that can be hard even. Here, a lot of times I see people want to minus the 6 first. And I can't because it's part of the fraction. So, right, once I times by 3, and then I can minus the 6. Right. I've always got to work on getting that thing that's furthest away from x out of there first, just like we did on number 4. So again, nothing too bad. Ooh, explaining time. No. You're basically just going to you're going to solve it like you normally would, except what you're telling me to do, you're actually going to write it down. So like here, what would I have to do first? Okay. So we're going to subtract 6. All right. Get that done. I don't know why I have 3 blanks here, but I don't think we're going to need them. And what's that last step going to be? Okay, multiply by 3, because that's the opposite of dividing. So I guess I gave us 1 too many blanks. That's all right. Yeah, maybe the answer is an explanation. I don't know. But we've got the idea. Because I'm gonna start doing some of these on the quizzes now, so you can actually tell me what's going on. Yeah, oh yeah. All right. Same type of thing working as we get over to the back, except now they're a little bit bigger, some of them. That's right. How do I get it there? All right. Last step. All right. And then again, whenever the arrow is there, make sure the arrow doesn't turn into an equal sign all of a sudden. That does matter. So if they're inequalities, make sure that they're getting to hang out there still. All right, let's see. 10, we got a little twist. We got some parentheses working. Distribute. When I distribute, what am I doing? Am I adding, multiplying, dividing? What am I doing? Multiply. Okay. So negative 3 times 4, negative 12. All right, so we got the parentheses out. We have distributed. Now what? Okay, add the 12. So I'm trying to isolate my x term. One step to go, but make sure you get all of it. Divide by negative 3 and switch the signs. Whenever we divide both sides by a negative, we have got to switch the sign. And for some of you, when you're even doing the division, you'll get the step right, and then we'll get the answer itself wrong. If you've got to double check in the calculator, that's okay. All right. 11. Yes. Because before I can get that 6 out of there, we will end up turning this in. Yep. I can't ignore all that stuff that's going on above them. Thank you. Sure. Subtract the 6. And what's your last step going to be? And then divide by 3. Whenever we're doing an inequality or an equation, it's all about doing opposites all the way through. Now, there's only one slight difference between number 11 and number 12, but let's see if we can figure this out. Yes, yep. I've got to, before I can multiply by 4, I need to get that part that's furthest away out of there first. So I need to do the plus 6 part first. Now I can bring it in, and now I can do the multiply parts. Again, now the 4 is furthest away from my x. It's not directly connected like the 7 is. Get rid of the fraction. And just add the 7. Again, this is very much a patience issue. We just got to kind of take our time, make sure that we're getting these part by part. Here's the other one that tends to be a killer. Right. Since they're on the same side of the inequality, I've got to combine like terms. And I have to watch my signs. Just because I'm combining like terms doesn't mean we're getting bigger in value every time. 8m and 2m is 10m. Negative 7 and 12, what's that going to get me? 5. If I survive that first part with the combining of like terms, then I'm good. Now what? Exactly. Again, we're trying to isolate, we're trying to get our m by itself. So minus the 5. And then the opposite of multiply is divide. So sometimes there can be several steps to some of these. I'm not going to lie, I'm not going to tell you that it's not that way. But that's how that works. Now here's ones that a lot of you skipped on the last quiz, or made up your own creative way of trying to do. How do you find the perimeter of something? Add up all the sides. So when I'm adding these up, I want to combine all the things that are alike. So how many x's do I have? 8. So I got 3, 1 is 4, 7, and 1 is 8. 8x. Yep, 4 minus 2 is 2, plus 4 is 6. 2 is 4. And I know it says do not solve, but I guess we don't solve it. I guess we got to follow directions, right? I suppose. Okay, but that's how that was set up. Again, the two-step equations aren't most of your problem. It's getting to this step is what our dilemma happens. Comes out, yeah, it doesn't come out real pretty. All right, now I'm glad we have 15 and 16 right next to each other here. Because there's one difference. I mean the types of problems they are next to each other. So, when I get here, some of you, when you're doing the quiz, wanted to set these equal. That's a perfect idea for number 16. Because it's a midpoint. Midpoint means we're going to set them equal. But if they give me the value of the whole segment, then I have to add those two pieces together. So if I'm adding them, I'm combining like terms. So x and 2x is 3x. What about with my 6 and my negative 8? Negative 2. And that equals the whole segment. You're like, oh, so then I just got to go through, get x by itself. How would I do that? Okay, 2 in there. What's that last step going to be? Divide by 3. End up with 14. So then, if I want to find mj, just plug it in. So mj is 2 times x, but I know what x is now, so I can plug the number in. Save. 20. So it's little things. I mean, we've got two segment problems right next to each other, but they're done completely different ways, depending on the information I have. Here, write the equation. Well, basically, I see it now. The midpoint, I take each part, and I set them equal. Then I could solve, and I could find the different pieces, and it wouldn't be anything too terribly awful. Okay. What ought to be done? Oh, yeah, it's just 20. Yeah, mj itself is 20. Because I stuck, mj is 2x minus, whoops, mj, oh. Yeah, we're just done. All right. Yeah, write the equation only to solve for x. So, yeah, just write the equation. Yep. So 17. Which equation below would you use to solve for x in the triangle? How many degrees are in a triangle? 180. Yes, I was going to say, this is one of those, as long as you know how many degrees are in a triangle, life is good, because it's not 360, it's not 90. I don't see the number there anyway. So I've got this. So sometimes that's not a bad deal. Angles, we were pretty good with this. How many degrees are there in a straight angle? 180. So, find my terms that are alike, because I'm going to be adding them together. What's the other side of my equation going to look like? 4x minus 2, because 3x and x is 4x. 2 and negative 4 is negative 2. And I solved this. Well, let's see. Add 2. And divide by 4, and you do get 45.5. I agree. Nope. Only when we're doing the story problems. So ABC then is 3 plus c times x plus 2. Okay, so it lets you go to C. Right, decimals are okay. Decimals are not a bad thing by any means. So good. So what's the difference then between like 18 and 19? Okay, so what am I going to set it equal to? 90. So equals 90. Combine like terms again because we're adding them up. 12 minus 2 is 10. And then just like we did on A, crank out the two-step equation. Minus the 10. Divide by 5. What's my x going to be? 16. And then CBD is this expression. So 3 times x, which is 16, plus 12. And I can find the measure. Huh? They're coming. Oh, yeah. You knew they were coming. It's a unit test, and we've talked about them this unit. So, yeah. Unfortunately, the wonderful stapler that we have been given when we were putting the copies together, when you try to put it in, it won't go to the corner. The only place it goes is where it's going there. I'm like, so yeah, not only do we have to stand in line to put staples, the stapler puts the staple like in the middle of the page, like it doesn't know what it's doing. Then we will take the pages apart and put them back together. All right, story problems. Here we go. Mr. Harper charges $10 for each shirt he sells. If he spent $224 on a press and supplies cost him $6 per shirt, how many shirts must he sell to break even? I don't know. Setup plus cost equals revenue. Let's find out. What's my setup cost? $224, because I had to pay for the press before I could start. Cost me $6 a shirt. 6x, because x is my number of shirts. And how much am I going to be raking in for every shirt? X. Well, I want to get all the x's to the revenue side. Okay? I think that sounds good. And then just divide by 4, because we're multiplying. Yep, 56 shirts. Good call. Good call, good call. For those of you on these that sometimes you like looking for a shorter way to do things, it's kind of interesting. Josh, when he was here the other day, said, Mr. Harty, I got a shorter way of doing this. And I'm like, okay, what do you do? He goes, well, here's what I've been thinking about. If the shirt costs me $6, and I'm selling it for $10, I'm making $4 on every one. So why do I have to do all this? Can I just say, well, it's how much I make per shirt and divide that in? Yes, you absolutely could. So if you like finding ways to shorten things up and that doesn't be clicking for you, shoot, do that. I'm good with that, as long as we can find a way to get to the answer and show it'll work. All right. Oh boy, our favorites. The width of a rectangle. The width of a rectangle is, there's my equals, 6 centimeters more than twice the length. So, what's twice the length? Forget this part. Twice the length. Length is L. L times 2, or 2 times L. Twice the length. And 6 more. Already pausing for a moment. He's not amused. So when I'm doing these, okay, when I'm doing rectangles, you've got to make sure not only that you're paying attention all the time, because that's how you miss out on things, but also that you're noticing here, I've got to use W and L. The width is, so I've got to do W equals, I can't switch it around and do L, twice the length and 6 more. So the perimeter is 60. Okay, well that's here on all of them. So if I look at this, let's think about this for a minute. Now let's see. If I drew a picture, let me get on the screen here. If my length is L and my width is 2L plus 6, I'm looking at it and I'm going, okay, so I've got two of those, and I have two of those. What's the difference between B and C? Yeah. And I know that it's plus, so it's got to be B. Well, but you guessed well. Okay? All right, equations. We will continue. All right, now we actually get to work one of these. Yes. Have I already mentioned on this that this test, when we take it early next week, is going to be approximately 20% of your grade? No. So, it's going to be a prime time opportunity. Harty again on delay, waiting. I'm happy for you, but that still doesn't mean you can sit and just talk to everybody. Why? Thank you. So, the length of a rectangle is 4 times the width. What's this going to look like? 4W. Okay, so when I do this, my perimeter is 2 lengths and 2 widths. They tell me what the perimeter is, so I can plug that in. Okay, well that's where we're going to take our time. 2, do I know what L is? Yes, this is my L. I'm going to plug this in for L, for W. And then I don't know what W itself is quite yet. Okay? So now you'll notice I'm down to one variable, just W. Multiply, yeah, just 2 to the 4, Perfect. And then I just combine the W's, and I go ahead and divide. But I'm not quite done just because I know what my width is already. Because the problem says find the length and the width. So my length is, since it's 4W, it's going to be 4 times the 4 that I just found here. So I'm going to replace the W with its value, which gets me my length. But again, the value you plug in can change. Sometimes you may be told the width is something, and that's all I'm going to be able to do. So yeah, this can get to be a little bit on the lengthy side. All consecutive integers. Oops. Yeah. Let's see where we're at here. All right. We're going to knock out 23 and 24, then we're going to stop. So, consecutive integers. Remember, come on, stick with me for 2 more problems. X, and if I want the next number, I'm going to add 1 to it. So if I'm looking for 2 consecutive integers, it's x plus 1 equals 32. Oh, that's interesting. This is going to be difficult. I'm not gonna get integers. Shoot. I messed up 32. I was supposed to be 33. Because I'm looking over here and I'm like, why is this not working? Oops, I put the wrong number down. My apologies. It's 33. Let's fix it. It's supposed to be 33. Yep, since we're adding, it'll be 2x's plus 1 is 33. Now what? Minus the 1. And what's x? 16. So I divide it by 2. And then add 1 to it. 16 and 17. Last one of the day. No. Well, I'm trying to find 2 numbers in a row that add up to that. So, yeah. Yes. If I'm ever looking for even or odd integers, instead of adding 1, I'm going to add 2, and if I have a third one, I'm going to add 4. Because if you think about even integers, they go up by 2 each time. So x plus 2 plus x plus 4 is 66. So combine like terms. I'm with you. Now what? Minus the 6. Not 21. It is 20 plus 2 more is 22, and 20 plus 4 is 24. Nicely done. We'll finish up part 2 of this on Monday, along with some extra credit review problems. Yes.